Now, dear children, we will go to the next topic. As I said in the last YouTube video also, that means we define one of the type of wave other than this progressive wave, and that is called stationary wave or standing wave. Yes, stationary wave or standing wave, because this chapter is completely based on stationary or standing wave. And you know the word stationary means the wave which does not looks like, which is not moving. Means although the wave propagates in a medium, but it looks stationary or it looks standing. It means it looks like it is not traveling at all. Okay, such type of wave can be defined as stationary or standing wave. Now this type of wave basically observed in a medium when two identical transports, two identical transports or longitudinal progressive wave. You know, progressive wave can be classified in two types. One is transverse wave, one is longitudinal wave. And this transverse or longitudinal wave which propagate in a medium is actually due to the vibration of the medium according to the direction of propagation of wave. Okay, but if there is a transverse wave or longitudinal wave, but what? Two identicals, not only one wave, that is two identical transverse wave or two identical longitudinal wave, longitudinal progressive wave, if they travel in the bounded medium. Bounded medium means like if they travel in the string of a sitar or guitar. Okay, because string of a sitar also vibrate. The vibration of this string of a sitar guitar may propagate waves. Okay, but what is usually happen, like when two identical transports or longitudinal progressive wave travel in a bounded medium with the same speed, both the wave travel with the what speed? Same speed, but in what direction? Opposite direction. But in what direction? Opposite direction. Then usually what happens? These two waves get superposed. That is by the superposition of two waves. And superposition means due to the what? Interference. Okay. By the superposition of two waves, a new type of wave will produce. And this wave which produce will appear stationary. Will appears what? Stationary in that medium. It looks like the wave is not propagating at all. It's not traveling at all. And this wave looks like stationary wave. Looks like stationary in a medium. And such type of wave is called stationary wave. That means the wave which that we have defined is called stationary wave. That means this wave is called what wave? Stationary, or we also define as standing wave. Standing what? Wave. So standing wave or stationary wave is a type of wave which actually propagate, which also actually appears in a medium by the superposition of two identical transports or longitudinal wave which they travel, okay, in the bounded medium. So remember this travel in the what medium? Bounded medium, okay, with the same speed but in the what direction? Opposite direction. Such type of wave is called stationary wave or standing wave. Now we have number of example of this stationary wave or standing wave that can be observed in day-to-day life. Okay, now for that let me just give you an example. When a wave is sent along a string, you take a string like string of a sitar or guitar, okay, or any string which is bounded by two fixed surface or rigid surface, or it can be one rigid surface or one open surface. Okay, so under this case what happened? When a wave is sent along a string, this wave gets reflected from the end of the string, because the string is provided by the boundaries. Okay, and the reflected and the incident wave will superpose to form a stationary wave or standing wave in the string. Means when some disturbance is produced in the strings, like if these are the both rigid end of the string, and when you made some disturbance in the string, this wave goes incident and get reflected back. But what happened with the boundaries, okay, or with the rigid surface? Okay, so what happened under this case? One of the wave, incident wave, and the reflected wave, which pass or travel with the same speed and with the same frequency, almost with the same frequency, but in the opposite direction. But these two reflected or incident wave in a string get superposed each other, and when they superpose each other, okay, then it forms a stationary wave or standing wave. That means we see a wave which is like stationary, which appears as what? Stationary in the string. And such type of wave is called stationary wave or standing wave. So the vibration of the string of sitar, guitar, which is produced as what wave? Observed as what? Stationary wave or standing wave. But in case of a string of a sitar or guitar, what type of wave propagate? A transverse wave. And two transverse wave, the incident wave, transverse wave and reflected transverse wave, superpose to form a stationary wave. That's why a transverse stationary wave are formed in the string of sitar, violin, guitar, and all. That means all these musical instrument, string instrument, okay, produces what? What type of wave? Transverse stationary wave. Similarly, stationary wave can be a longitudinal stationary wave also. Like a longitudinal wave can be sent in an air column of a what? Pipe. So when wave is sent in a pipe, okay, the air column of a pipe vibrate and produce what type of wave? Longitudinal wave. Because the vibration of air column produce what type of a longitudinal wave. But this air column, the longitudinal wave which makes produce in the air column of a pipe, get reflected from the end of the pipe, and the reflected and the incident wave, they also superpose, okay, to form a stationary wave in the air column. So what type of stationary wave will form in the air column of a pipe? A longitudinal stationary wave. And this longitudinal stationary wave which are formed in the air column of like the instrument like flute, okay, veena, whistle, okay, these are all the instrument, okay, where the air column vibrate and produce what type of wave? Longitudinal stationary wave. But why longitudinal stationary wave? Because as I said, the wave, one of the wave get incident on, okay, in one of the direction and get reflected from the end of the pipe, so that this reflected wave and incident wave, they superpose each other to form a stationary wave. But what type of stationary wave is formed? A longitudinal stationary wave, okay, that is formed on the air column of what? This instrument. That's why the stationary wave can be observed with a transverse wave and it can be observed with longitudinal wave. But the most important condition, as you learned, is this wave can be seen or appears as stationary is actually due to the superposition of two incident, okay, and reflected what? Transverse or longitudinal wave which propagate in the opposite direction. And such type of wave is called stationary or standing wave. And basically this type of wave is observed in the musical instrument, like the string instrument, like the instrument like flute, okay, like veena, whistle, okay, these are all the, okay, trumpet, these are all the instruments where this type of stationary wave can be observed. Now in stationary wave we can observe 2 points. These are the two important points that we need to mark and to understand, okay. And one point is called notes, another is called antinotes. So basically these are important points, okay, to be noted down. One is called notes, N-O-D-E-S, notes, another is antinotes, okay. Now in a stationary wave, some particles of the medium remains permanently at rest. Permanently at rest means no displacement, and these points are called notes. So note is usually marked by letter N, okay, and antinote is usually marked by letter what? E. So note is that point, okay, that particle of the medium, that point in which the particle of medium remains permanently at what? Rest. That means at note what happened? The particle of the medium, the particles of the what? Medium remains, okay, remains permanently at rest. The permanently at rest means no displacement. The particle does not produce any displacement at that point, and such point is called notes. Similarly, there are other particles of the medium which undergoes a maximum displacement as compared to the other particle, and these points are called antinotes. So antinote is simply a point in a medium. It is also a point in a medium, okay, in which particles of a medium undergoes what? Undergoes maximum displacement, undergoes what? Maximum what? Displacement. And this maximum displacement which produced as compared to other particles of the medium. Okay, and this maximum displacement can occur on either side from the mean position or rest position, and such points are called antinodes. So remember children, this in case of stationary wave or stationary wave or standing wave, we can always observe the 2 points. One is called node, another is called antinode. Node is the point which has no displacement of the particle, and antinode is the point where there is a maximum displacement of the particle. Now, in order to understand the point node and antinode in stationary or standing wave, let me take the example of the stationary wave observed in the string instrument, like the vibration of string instrument like sitar, guitar, which has 2 rigid boundaries. Okay, so both are rigid boundaries, and this is the string of a sitar or guitar which vibrate, and when it vibrate, both the wave superpose. Basically in stationary wave or string of a guitar or sitar, whatever vibration will occur, transverse vibration will occur. Okay, transverse wave will occur, and transverse wave occurs in such a way so that the particle medium vibrate perpendicular to the direction of propagation wave. If the wave propagate in this direction, this get reflected in this direction. So incident wave and reflected wave travel with the same speed but in the opposite direction, and these 2 waves superpose each other in such a way so that there is a formation of the wave that is observed on the string, and this wave exactly looks like stationary or standing. That's why it is called stationary wave or standing wave. But in the stationary wave or standing wave, they are the point, like this point. If you see, this is the point which is connected with the rigid wall, remain fixed. That means the particle of this particle at this point will permanently at rest. No displacement occur by the particle at this point, and these points are called node, and we mark the letter N. So node. Similarly, there is a point where the particle have a maximum displacement. This is a maximum displacement. Particle occur what displacement? Maximum what? Displacement. Even this both sides, and this particular point are called antinodes. So point related to this maximum displacement is called antinode. So this point related to maximum displacement on both sides, positive side or negative side, is called antinode. Similarly, this is a point called node because this is the point where the particle have no displacement at all. No displacement means the particles at rest, that is at mean position only, and such point is called node. Again, this is antinode, where the particle has maximum displacement positive side or negative side, antinode. This is node, antinode, node. Similarly, antinode, similarly node will form. So such type of node, antinode is always formed or observed in this wave called stationary wave or standing wave. Okay, so this is one of the example taking with the vibration of string instrument. Okay, where we can observe the node and antinodes under which wave? Standing wave or stationary wave. So this is the example of stationary wave with the term that we define called stationary node and what? Antinode. Now in the next YouTube video, you basically learn the characteristics of stationary waves.